Okay, so this is kind of a different form of video than I usually do. It's not really going to be structured. I just wanted to, I guess, kind of just put my thoughts out there. I went to the Intel Museum yesterday here in Silicon Valley and picked myself up a T-shirt. It's really cool. As part of my Silicon Valley kind of vlog, I'm gonna have pictures of all the stuff I did, including including my trip to the Intel Museum. It was really cool. Didn't get to meet Pat Gelsinger, but maybe next time. So, what is internship? I'm here for an internship in chip design, learning how the whole process works, working with an EDA company. So, you have to learn all about how a chip is manufactured so that you can help your customers when they use your EDA software to design their chips. And what I've just been kind of thinking of with the recent, I was watching the Apple keynote lately, how their new goggles, Apple Vision, is powered by their new M2 chips. And I also was looking at Jim Kelly, who was talking about this big project he's doing with RISC-V. And it's supposed to be like one of the biggest like RISC-V projects up to this point. I would love to see a RISC-V based chip with the same level of power that we see from Apple. That would be really cool. So I can't wait to keep track of that project. But what these pieces of news have kind of got me thinking, along with this internship, is kind of where the future of chip design is going. And what I've kind of come to realize is that it's going to be a very, very big space. I think what you guys have to understand is more people are making chips. There are more people making chips now than there ever have been. It's going to be a bigger and bigger industry because it's getting easier and easier to design them. So, for those of you who don't know, Amazon, their cloud computing division called Amazon Web Services, or AWS, they're making their own chips for like supercomputing and I think streaming needs. Meta, Facebook/Meta, are making their own chips specifically for, like, I think they saw that they're putting it in like their 3D or their VR headsets or whatever. So all these companies are hawking. Google is making a chips for I don't know what, but they're making their own chips also. So these companies are starting to make their own chips because they want to be able to have the freedom to do whatever they want. And the R&D for developing their own chips it's because it's getting so easy. It just makes it worth it from a cost perspective. So, and we're seeing startup companies as well, especially with this AI, how this AI trend has exploded onto the mainstream. We're starting to see a lot of startup companies developing their own AI related chips as well. So I think we're going to see a lot of new chips manufactured in the near to distant future. But this also brings up an interesting question when it comes to software, because for the longest time, AMD and Intel were the two big dogs in town. Apple is really the one who kind of shook everything up, because with AMD and Intel, software, you had x86 and that was it. Now, obviously, that was different on the phone space with phones using largely like ARM instruction sets with like the Qualcomm and Motorola and whoever was making phone chips. I'm not sure who it is now. Now it's Apple with their own silicon in their phones. But you were limited, at least on the desktop and the laptops and the data centers and everything that wasn't mobile. You were limited to the x86 instruction set. So all the software just ran. It just worked because that's what it was for. But now, Apple's kind of been the game changer, switching over to ARM. And with more people hopping on this bandwagon of making their own chips, I mean, don't get me wrong, I love that there's going to be more hardware out there. I love that chip designs are going to be more common and that there are more people making them. That's great. I love it because I love innovation. The one question it does bring up is the software, though. I mean, I don't think in a year we're going to see 50 different types of CPUs in laptops. I'm not saying that at all. But I'm saying that, the day of, different devices are going to have different instruction sets and um, different chips in them is a reality that I think is going to be coming. So the software is going to have to be written according to what instruction set you want, and it's going to have to be ported if you want to use it on different instruction sets. That's something that you have to consider as well. So it's going to be kind of interesting how we're going to be seeing more designs hit the market, and then you're going to have to develop the software from the ground up. And what it kind of reminded me of is it's going to kind of take us back to the time of the like the 70s and 80s, the really kind of early days of computing, at least computing at home, where you have to write software, like you had to write software specific to the machine that you were working on. You couldn't just write it on anything and run it on anything. You had to make sure that it was compatible with your particular system. Because back then, I mean, you know, anyone could make a beige box with a chip inside of it and push it out the door. I mean, you could sell computers or make computers like hotcakes, and they sold too. They flooded the market with actually. And I think that we're kind of coming full circle to that again, because back then, chips were easy to make. Now they're complicated because, you know, they're too complicated to make by hand. Back then they made them by hand. They're too complicated to make by hand now. But what we're doing is we're coming quite full circle because we've abstracted the chip making process to a point where anyone can do it. You just put in a bunch of building blocks and say, you know, poop me out a design, generate a GDS file, I can send it off to TMC and have it fabbed. Yeah, it's really cool. It's really cool that we're doing that. So the whole process for making a chip is a lot easier than it was just a couple years ago. And I think that that's what we're kind of starting to see now with more people kind of adopting their own designs. It is really, really cool. FPGAs also play a part in that, where you can just kind of configure it to do whatever you want and run your own instruction set if you want. Because for, you know, maybe not consumer products, but certainly on a lower level, like a microcontroller level, you don't really need huge instruction sets to run simple things. So people, I don't know, maybe we might start seeing the advent of new instruction sets for, as well to complement new chips. I'm not sure. That's interesting though. But yeah, I don't know. I'm really excited, and I think that the future is going to be really, really cool for this. This internship's really kind of opened my eyes to that a lot, and the news kind of supports it. So, yeah, I don't know. I just wanted to sit here and kind of put my thoughts out there for whatever it's worth. But I think it's interesting to think about this kind of stuff and kind of where we're headed in the future. But let me know what you guys think. Let me know if you have any kind of predictions. I'm curious to hear what other people think. But it's definitely going to be cool, and I think that I'm very blessed to be in this line of work. And I think that the industry is going to be so awesome. And, you know, as someone who's always been a tech enthusiast, I'm really excited for where this is going to go. And I'm excited that I get to witness it all. I'm on the forefront. I'm here in Silicon Valley. So yeah, let me know what you guys think. Like, subscribe, comment, all that good stuff. And I'll talk to y'all later.